flour. So here's your ratio. Oh, flour to water is 1 to 6, but I want to make more. I want to use 8 cups of flour. How much water do I use? Yeah, so I can just multiply. If I multiply that side by 8, I can multiply that side by 8, and I get 48. Sometimes we have like in time and stuff like that. There's ratios. What's a rate then versus a ratio? Yeah, so speed is a rate, yeah. So what's the difference? So ratio is like flour to water is 8 to 48. This is a ratio. A rate then is like a speed, like you're saying. So you might say kilometers per hour, yeah? Okay, what's the difference between these two ways of writing? Notice when you were saying flour, cups of flour, yeah? Well, and cups of water, or cups. One thing that's different is the units. Notice the way the units here, flour to water, are the same unit. That's one thing. Whereas speed, if I say 20 kilometers per hour, that one unit is kilometers and the other one is hours. So that's it's a distance and a time, yeah? Or speed, yeah. Distance and a time. Okay, yeah. And also there's a rate uses this has to be 1 unit. Whereas in our ratio, and you saw this with the sweets earlier on, we had red to blue, wasn't it? And it was 2 to 3. Whereas anytime you see a rate written down, it's always when one thing is 1 unit. Kilometers per hour, meters per 1 second. Miles per hour, that's all 1 second or 1 hour. Okay? So we'll look at rates a little bit later. We'll focus on ratios for now. So one thing that's crucial with a ratio is they're in the same unit. So, for example, where mistakes might happen in ratios if we compare, what's the ratio of 1 hour to 30 minutes? 1 hour to 30 minutes. What's that ratio? 1 to 30?
60 to 30.
Okay, so you're going straight to yes, it must be in the same unit to compare. So we're comparing two things. They must be in the same unit. If I say it's 2 kilometers versus 100 meters, 2 kilometers compared to 100 meters, well, that's not 2 to 100. That would suggest that this one is 50 times more than this one. This one is not 30 times smaller than this one. If I wrote 1 to 30, that would be a mistake. That would suggest there's 30 minutes for every hour. No, that's not right. Whereas if we go 60 to 30, have the same units, that's in minutes. Oh, spell it right. That's in minutes. That's also in minutes. Now they can compare 60 to 30 for every 30 minutes. There was 60 minutes of the other thing. Would you say that was the simplest way of writing that?
2 to 1.
2 to 1 would be the simplest way. Yeah. So I can simplify ratios the same way I simplify fractions. We kind of did an unsimplification here. If I want to simplify a ratio, I make sure it's in the same unit, and then I can do what to both sides? Divide. What number did I divide by?
30.
30, yeah. So I divided both sides by 30. Okay, this one is wrong. 2 kilometers to 100 meters is what to what? 2,000 to 100. Okay, and how can I simplify this? I divide it by, well, you could divide it by 2. You'd be...
Divided by 100.
Probably by 100, yeah. It seems like the easiest. So dividing by the highest common factor, greatest common factor, is usually the best idea. 20 to 1. So this one's 20 times longer than this one. That makes sense. Okay. So if it's just numbers, we can always simplify a ratio. So let's use one with no context and just say 25 ... 15. 25, maybe 25 boys to girls or something. That's our ratio. How do I simplify that one down?
5 to 3.
Yeah, so you're thinking, right, what's a common factor both sides? And you're thinking 5. So you divide both sides by 5, a bit like dividing a fraction. by numerator and denominator by the same number, and I get 5 here and 3 here. Very good. Okay, so if I have whole numbers like that, just find something in common, divide. What happens if I have something like 64 to 48, and I go, what's the highest common factor? I don't know. Maybe, I definitely know 2 divides in, so I'll just divide it by 2. Is that okay? Yeah, that's fine. 32 to 48, half them both. But then I can go again. Same as simplifying fractions. If I haven't fully simplified it, just keep going. What can I divide this by? 2, 4, 8. Let's pick the biggest one this time. We've seen this, 8. This one divided by 8 is 3. So it's actually a ratio of 4 to 3. What happens if so we know if they're not in the same units, we make them the same units, then divide. What happens if they are those lovely numbers we like, fractions? 3/8 of something, let's say it's 3/8 of a kilogram of flour. For every 3/8 of a kilogram of flour, I've got to put it 1/7 of a kilogram of sugar. And that's not nice. So it's just 3 to 1 or something, is it? Yep. You can make it into decimal, yeah. Is there any other way we compare fractions? Right? Oh. Boom. If we have the same denominator, I can compare straight away. What's the common denominator between 8 and 7? 56. Just multiplying these two will get me a common denominator. So if they're both written over 56, I can compare them. A bit like you could compare 3/4 of an hour versus 1/4 of an hour. I know that's 3 to 1. So what's my numerator here? So I'm kind of cross multiplying it, haven't I? 21 and 8, yeah. Okay, so what's my ratio?
21 to 8.
It's 21 to 8, yeah. I can ignore the fraction. Why? For the same reason when I say, if I have 3/4 of an hour to 1/4 of an hour, what's the ratio? How much is one bigger than the other? Well, it's 3 to 1. One is 3 times the other, so I can just say that's 3 to 1. So if I have the same denominator, they already are compared in the same unit. Same as way, I don't say this is 30 out of 60 minutes. I just say it's 30 minutes and then simplify it. Okay, that's if we have a fraction, we find a common denominator. What happens if we have a decimal? What do we do then? So let's say we have something like 0.02 compared to 0.108. Ren?
You can times them both to get like a bigger number or not a decimal.
I would do exactly that, yes. I would sometimes you can turn them into a fraction, or you can just look at them. This is a bit tricky. I would times first, like unsimplify it, but make whole numbers. It's far easier to deal with whole numbers. What would I times both sides by? 1,000, yeah, 1,000. Multiply this by 100, I'll remove the decimal, but there'll still be a decimal in this one. So there's 3 decimal places over here, multiply by 3 zeros, which is 1,000. So if I multiply both sides by 1,000, I end up with, what's this multiplied by 1,000? 20, isn't it? Move it 3 spots. 1, 2, 3, and a 0, yeah. And what's this one? 108. Okay, now I have 2 whole numbers, 2 even numbers, so they definitely can divide by 2. I think they probably could divide by 4, but we'll see. 2 is 10, and 2 is 54. What'll I do? 2 again, 5, and divide by 2. 27, yeah. 27. Can I go? Well, this is a prime number, so this would have to be something, and there's no 5s. Okay, so with decimals, this is a decimal example. Multiply first. Multiply first. With fractions example over here, use a common denominator. And then if they're in different units, make sure they're in the same unit is the basic thing. So if you want to take a note on that, I'll give you a second. Maybe put the decimal example just so you remember. And then I'm going to